This week's challenge features an interestingly structured dataset. So let's take a look at that first to get ourselves familiar with it. So what we have is information about flight delays spread over 3 different rows. So we have our airport, so in this example JFK, it's a departing flight and it is 9 minutes late taking off. Whereas our flight from Seattle is an arrival and it's 28 minutes late arriving to the airport. So how do we go about sorting out this data set? We could fill down both of these airport and type rows so that we only then so we have all of the information contained in the third row of each flight delay grouping. But that's a bit tedious to have to go through the process of filling down twice, as it can be quite a lengthy process, as you may remember from Preppin data a few weeks back. So instead, what I would suggest is that we flag wherever there is an airport in a row, so where an airport is not null. And then we would have, if I just show you our flag that we have there, then what we would have is an indication of where our flight delay information is restarting to a new flight delay. And then if we were to do a running total on this run number, then you can see how these values would all pick up the number 1, these values would then be 2, and so on and so forth. And it would just give us the grouping of the different flight delays information. So how do we go about doing that in Tableau Prep? We basically need to join our dataset back onto itself. So we add in a clean step after we've added this flag, and we join it back onto itself. And our clause here is that the record ID is greater than or equal to the record ID. So the record ID from this flag airport step here is greater than or equal to the record ID in the clean step that we added after it. And if we take a look at what that does to our dataset, it basically means that we have, if I do a detail on our record ID, we have 1 row for our first record, and then we have 2 rows for our second record. And you can already see that for our second record in our original dataset, we have the row number 1 and 0 there. So when we sum these 2 numbers together, we will get a 1 rather than the 0 that was there before. And if I continue that on to number 3, you can see that we've got, if we sum that, that will still be a 1, whereas if we go to 4, then we'll sum that and it'll become a 2 for us. And that's basically what we're trying to get to, that grouping for the flight delays. So then what we're going to do is we're going to group on our record ID, we're going to sum up those row numbers, and we're just going to take the max value for our airport type and delay. And that will all kind of make sure that it brings through the right information for us. So if I now take a look, say, at my row number 1, then we see that we have those 3 rows associated with JFK departure and a 9-minute delay that we had before. And it's for record ID 1, 2, and 3. So now what we want to do is just remove that detail of the record ID and make sure that we get everything on one line. So we use another aggregate step to group by the row number this time and to just take the max of each of those airport types and delays again. And now if we look at that row number 1, then you can see we've got our departure from JFK is 9 minutes delayed. Sorry, departure to JFK. Don't want to confuse things there. But that's great. That's exactly what we want. We want a row per delay. And if we take a look at that data set now, then we can see that we've got 6 airports. And it looks like potentially, now that we're kind of able to focus on the data itself, we've got some inconsistencies here. It looks like this JKF is a mistype, a typo. And it should probably be grouped together with JFK. So let's just go ahead and create that grouping. We literally, if I show you just quickly as an aside, we literally, if we go to common characters, then it will recognize that JFK and JKF are exactly the same, just in a different order, and it will group those together, which is all that we need to do at that step. Now we're able to aggregate it up a little bit further so that we have the total delay for each airport and whether it's departure or arrival. And we can just do some renaming to name this the number of delayed flights from the number of rows. And we can join on the on-time dataset. Now the on-time dataset has just the airports, the number of flights, and whether it's a departure or arrival. And that's just kind of telling us how many flights didn't have any delay at all. So that's useful for us to be able to calculate the average delay, because obviously we need to take into consideration those 0 delays as well when we're doing that. So we join them together. We update our number of flights column so that it's the number of flights plus the number of delayed flights, just bring those into there. We calculate our average delay. If I just zoom in on that, then we have the delay over that total number of flights now, just rounding that to 2 decimal places. And then we calculate our percentage of flights which were delayed. And that's simply doing the number of delayed flights over the total number of flights, multiplying it by 100 and rounding it to 2 decimal places as well. Removing some additional fields, and we are left with our output, which is showing us which airports may have the best chance of not being delayed. So for example, going to this airport here, arrivals from that airport are quite often delayed, but the delay time isn't too drastic. Whereas, yeah, if you're going to be delayed arriving from Seattle, then it's going to be a larger delay. So hopefully that was a fun challenge for you. Hopefully you learned some new techniques, and thank you very much for watching.